McCormick. I'm in 6th grade, and the title of my experiment is Thousands, Not Billions. In the 1960s, Dr. Robert Gentry found polonium halos inside of granite, outside of the uranium decay chain. Polonium halos are only supposed to be in the uranium decay chain. Where he found the polonium halos was inside granite, inside this black substance called mica. Now, what polonium halos are is a byproduct of decaying uranium, and polonium halos decay extremely fast. This green halo, which is polonium-218, and this is a picture of a polonium halo. This is the green halo, and it decays within 1/10 of a second. This blue halo decays, which is this one, decays in a minute, within minutes. And then outside of this orange one, this orange halo, here's this one, decays in seconds. So, my question is, if polonium halos decay this fast, and if granite cooled over a long period of time, or over millions of years, how is the polonium halos inside of granite? My hypothesis is that granite was not cooled over a long period of time, that it solidified instantly. And when I was doing research for my hypothesis, it led me to carbon dating, which I will talk about in a minute. So, for my experiment for the granite, I took Alka-Seltzer and I put it in water. And when you put Alka-Seltzer in water, it bubbles up like this. Now, what I was trying to do was either freeze the bubbles or to capture the bubbles to make them not pop. Now, the bubbles will go away in about 30 seconds, but so they go away too fast to freeze. But if I tried to capture them by cutting off the air, that might work. So what I did was I took a jug, filled it up to the top, and then I screwed the lid on before anything could get out after I put the Alka-Seltzer in. That didn't work because it leaked. So the only thing that I could think of was that the granite had to harden instantly, or that's the only thing that could make sense to me. So for carbon dating is based off of carbon-14. And how carbon-14 is made is from nitrogen. Now, carbon and nitrogen are right next to each other on the periodic table of elements. So it's easy for them to switch back and forth between each other. So carbon-14 is made from nitrogen floating around in space. And when galactic cosmic sun rays hit the nitrogen turns into carbon-14. Now, the carbon-14 gets into testable material two ways. One way is when it combines with calcium, it makes calcium carbonate, and the calcium carbonate goes through the minerals, picks up the minerals, drips in caves. And when it drips in caves, the minerals get left behind, creating stalactites. And the other way it gets into testable materials is the plants absorb carbon. So the carbon-14 gets absorbed by the plants. The animals eat the plants, and we eat the animals. They eat the plants, or we eat the plants. So us, the animals, and the plants we're all assumed to have 0.0000765% of carbon-14 in us, which is the same as the atmosphere. So carbon-14 has half-lives. So if you have a handful of carbon-14, if you wait 5,730 years, half of that carbon-14 will turn back into nitrogen. And then if you wait another 5,700 years, half of that carbon-14 would turn back into nitrogen. So it would go from a half to a fourth to an eighth to a 16th. It's not enough to measure. And so if you have, this is what your handful of carbon-14 would look like. Then after one half-life, it would look like this. After 2, 3, 4, 5 half-lives, 6, 7, 8, 9. So technically you never run out of carbon-14. And so carbon-14 is radioactive, and Geiger counters measure the amount of radioactive or it measures radioactive materials. So when the Geiger counter, it clicks and click, and the more half-lives something has been through, the less carbon-14 it has. So if it clicks twice in a minute, then it would end up having, it says it would be 17,190 RCY, radiocarbon years. Now, there's flaws in carbon dating. If you found a fossil and you could measure how much carbon-14 is in the fossil, you can know what the rate of decay is, but you don't know how much carbon-14 was in the fossil when the animal died, or when whatever the fossilized thing is. But you don't know if it's always decayed at the same rate, and you don't know if the atmosphere was the same a long time ago as today. So I did an experiment for this also, and what I did was I took 4 candles and burnt them exactly a half an hour, and each one of them burnt exactly an inch. And so if it burns an inch a half an hour, using simple math, if I burnt a candle for 2 hours, it would burn 4 inches. So I burnt one for 2 hours. I burnt a candle for 2 hours, and I was a whole inch off. It ended up burning 3 inches, because the further down you get in the candle, the thicker the candle gets, the wax gets. So the longer it would take for it to burn, which is a perfect example of if it's always decayed at the same rate. So carbon dating definitely has something wrong with it. And for some flaws is the lower leg of a mammoth had a radiocarbon age of 15,000 years old, RCY, radiocarbon years. Well, its skin was 21,000. One part of a baby frozen mammoth was 40,000, another part was 26,000, and the wood right next to it was 9 to 10,000. A freshly killed seal was carbon dated as having died 1,000 years ago. So, again, there's something really wrong with carbon dating. Now, in 2001, there was a physicist, Warren Beck, at University of Arizona, who did a science test with his students. Their conclusion was that atmospheric percent may have changed up to considerably twice as much in the past. So, after doing my whole science project, my conclusion was that granite was made instantly, not over a long period of time, not over millions of years. It was made instantly because Polonium halos in the granite prove that the granite was made instantly. And that carbon dating does not prove evolution. It doesn't prove an old Earth. It doesn't prove anything. It's based off of too many assumptions. Thank you.
Funny to me.